topic of today's lecture will be the entity relationship model, or the ER model as it is popularly called. We had seen in a previous day what an entity relationship model looks like when we discussed the simple situation of the library database. And we said that it consists of three major components, one called the entities, the other are the attributes of the entities, and some called the relationships. Today we will see the conceptual modeling using the entity relationship model in more details. The entity relationship model is a conceptual model by which you conceive the structure of the database, mention the relationships between the different components, and identify the constraints that occur in the integrated design of a complete database system. So, the first and foremost idea of an entity relationship model is the concept of an entity. We shall slowly understand what an entity means. That is, we will not give a precise definition of an entity because it is slightly difficult to conceive of what a conceptual entity will be. But let us assume that for any database system there exists a set of distinguishable items. For example, in a library database we have got books. As we had seen in the previous day, in the library database we have got books which are a set of distinguishable items. Each book is a distinguishable concrete entity of the database. For example, users. These are also some distinguishable concrete entities of a database. So, an entity is a distinguishable object of a DB. The definition is still quite vague and we will elaborate slowly as to what it actually means. It requires some understanding to know what an entity means. So, we will pick up a few examples. Let us take the example of the library since we have started with it. In a library, a particular book, any particular book for example, compiler design by Aho, Sethi, Ullman, published in the year 1992, published by Addison Wesley, having accession number and call number in the library, is a clear distinguishable element of the library, and it is one of the entities. You can have another entity of the library this may be another distinguishable entity of the library. Another distinguishable entity of the library can be this is maybe a third distinguishable entity of the library, which is one of the suppliers. And there may be several other entities of the library, like library staff and other people, authors, books, so many things. So each such distinguishable object which can be identified for a particular database will be called an entity. Now there may be many entities having the same structure as a book, many entities having the same structure as a person, and many entities having the same structure as a supplier. Therefore, all those entities which have the same structure or are of the same type form what is called an entity set. Therefore, we have here maybe an entity set book, another entity set user, another entity set supplier, and so on. Now the same type needs to be elaborated a little further, and for that we define the concept of an attribute. An attribute is a mapping from an entity set or from an entity set into a domain. Let us see some examples. It specifies a type part of an entity structure and it is a mapping from an entity set to a domain of values. Consider as an example the entity set book. It will have several attributes as we have seen. It has got name, author, year of publication, publisher, accession number, call number. Let us for the time being concentrate on these attributes. Sorry. So the attributes which we may have are name or title. The second attribute which we will have is author. The third attribute which we will have is year of publication. The fourth attribute which we can have is publisher, accession number, call number, etc. Now, what are these? These are mappings to some domain of elements. For example, this is a mapping from the entity set book to a string. This is a mapping from the entity set book to another string, and this string may be having a particular size, alphanumeric string. This will be a mapping to an integer of size 4. Okay. So, integer of size 4. This may again be a mapping to a string. This will be another integer of size, say, 10, and this will be another string or a floating point number, whatever you decide it to be. Normally it is a string. So, these are the domains in which this is mapped, and the domains form the set of permitted values which can be mapped from this entity set using this attribute. So, these attributes define the structure or type of any entity. For a user, you will have several entities. We saw the previous day: card number, name, address, status, code, and several other issues. A supplier will also have several attributes: supplier name, address, maybe supplier identifier if it has got a supplier code which is provided by the library or the database. So, every database will have a set of entities and a set of relationships. So, let us go back and try to see a few examples of such databases and identify some of the core entities. This is just the beginning. We will see all of them may not be entities, in the sense that when the situation becomes more complex, there will be a lot of other issues. For example, if you have more than one author, how will you tackle it? If you have more than one publisher, how will you tackle the situation? You can easily tackle the situation in a simplistic sense by saying all the authors will be a string one after another, and if there are two publishers, it will be a string one after another. But we will see that we can get a much better design at the conceptual level than this. For the time being, let us concentrate on this one. Let us take another example. Let us take the example of a bank. Some entities which will be there in the bank are accounts, these accounts will have attributes: account number, then it will have balance, it will have type of account, savings account, current account. Another entity may be customers of the bank. They will have name, address. Another entity may be branches of banks. Which will have branch code, address as their attributes. Let us consider the student database in this institute. The database of the institute, that is courses, students, etc. So, academic database. Here our entities will be students, then staff, then courses, then fourth one will be rooms, fifth one will be periods or times, that is Monday fourth period, Tuesday third period, Wednesday second period. The rooms will be rooms in every department. And the attributes of a student may be like this: roll number, name, address, department, year, course. For a staff, it may be employee code, department, name, address, status, that is the type of the person.
Attribute of another entity.
Can an entity be an attribute of another entity? Well, it is not like that. An entity.
I'm talking about course, students, course, and your courses are also entities.
You are saying that a student is an entity, a course is an entity.
And the course is an attribute of the student.
A course is an attribute of the student. Oh, I have given a different name.
Course number.
Let us make this course number. Well, we will give different names to entities and different names to attributes. So let us call this course number rather than courses. So this will be the course name, department, and structure of the courses. Let us say name, department, type. Type is it is BTech course or MTech course. And let us put in another entity called subjects. This will be subject number. This will be semester, in which semester this subject is given. Then the department which offers this subject. No, we will not give a teacher here, because this teacher will change from time to time. This is not for a particular year. We will give a teacher and its relationship with this subject separately. Periods will be day of the week, Monday, Tuesday, Wednesday, and hour. Start time. And room will be department, room number, capacity of the room. This is in a simple sense what we can have for an academic database.
So can we have attribute course number for entity courses?
See, the name should be very clear to us. Can we have an attribute course number for the name courses? For a student, this course number is different. This course number is what is the course that he is taking. He is taking an MTech course or a BTech course. An MTech course of a electronics department may offer 5 MTech courses, and that may be the particular MTech course for the electronics department will be the course number. That is what it is. So whereas courses is a course name, department and type, and we can also have a course number here. You are right. Okay, we will see whether this course, this will be here or will it be part of a relationship which we shall define later on. The conditions under which what goes into an entity and what goes into a relationship will come a little later. So let us for the time being keep this open, and we will discuss it when we come to that position of courses and types. So since we have to move into that, we describe what is called a relationship. So the next important issue which we will have to discuss is a relationship. A relationship is normally an association or mapping between entity sets. Actually, between entities. For example, let us come back to our original database, that is the library database. And here we had two entities, the book and a user. And if this book has been issued by this user, then that information will be there in the relationship borrowed by. The relationship borrowed by is a mapping from the entity book to an entity user. So it is an association or mapping between entities. So given two entities, whether there is a mapping between these two entities identifies a particular relationship. There may be more than two entities, there may be less than two entities involved in a relationship. We shall see it later. But for the first and initial understanding, let us assume that we have got two entities and whether there is a relationship between these two entities. And all such relationships between the same entities which have the similar properties are form the what is called the relationship set. In the book and user, we had defined the concept of this relationship. We had the book entity. We diagrammatically represent it like this, as we had seen in the previous day. And we say this is the set of relationships from book to user relating those books which have been borrowed by a particular user. this relationship set supplied by relates the book, each individual book has been supplied by some supplier. So if this book has been supplied by this particular supplier, then this relationship or mapping exists from this book to this supplier. Now how do we express this borrowed by or this supplied by relation? This book has got certain attributes and this user has got certain attributes. So in the coarse sense or in the first look, the borrowed by relationship will have the book attributes of the book and the attributes of the user, and it will contain only in that set, it will contain all those books which have been borrowed by these particular users. For example, Aho Sethi Ullman may have been borrowed by Ajay Kumar Singh. A copy of compiler designed by Holub may have been borrowed by Pramod Kumar Rai. Another copy of Aho Sethi Ullman may have been borrowed by myself, P.P. Chakrabarti. Now, two copies of the same Aho Sethi Ullman are two distinguishable elements because they do not have same values in all the attributes. An entity set book. Now, in an entity set, you cannot have two duplicate elements in the sense that it is a set by definition, and since it is a set by definition, in that same set you cannot have two elements having the same attributes, values in all of the attributes. For example, you cannot have in the book entity set two books which have got the same accession number, same call number, same title and same everything. That is not the definition of a set. In the user entity set, you cannot have same username and same ID, same card number, 5 of them. If a person has 5 cards, you will not have 5 times, his name will not be there 5 times. Unless you define the cards to be different. If you define the cards to be distinct, then they will have 5 different. If you define one set of cards with one number, then there will be only one entry. So that is, these are all definitions, by definition, sets. This is also a set. It is a set of those elements of attributes and user such that this book has been borrowed by this user. This is a set containing attributes of book and supplier relating to whether this book has been supplied by this supplier. Now, the important question to remember here is that each and every element may not be mapped somewhere here, and each and every element may not be mapped somewhere here. That is the first thing which we will have to remember. For example, each and every book may not be borrowed by some user, it may be there in the library. There may be a user who has not borrowed any book. So, this relationship is a relationship and it is not a function in the sense that every element here must have a mapping with some element there. This is an important issue which has to be remembered, and this is one of the core issues when we conceive of the design of what is an entity and what is a relationship. Now, regarding book and supplier, normally when we conceive of a book and a supply by entity, we will normally assume that a book, it is not that for every book a supplier has to be there. This book may have been donated, some book may have been purchased in the library, in the sense some book may have been produced in the library, and there may be a supplier listed who has not supplied any book. All this is possible in this entity relationship definition which we have given just now. Is that understood? Moreover, other than the attributes of the book and the user, a relationship may have its own attribute, an attribute which is corresponding to this relationship and this relationship alone. For example, date of issue may be an attribute which may not be an attribute of the book, nor is it an attribute of the user, because the user may have issued 5 books. Whereas for this particular relationship, this attribute is there. Date of supply. This PCR is the price conversion ratio. For example, the dollar to rupee conversion rate. This book will have a price which may be in dollars or in marks. This person has supplied the book at a particular date, and for this supply, what is the price? What is the conversion ratio? What is the actual rupee price? This here, the price here will be the published price of the book. If there is an attribute price here, that will be the published price of the book, whereas an attribute here will be the actual price paid for the book in terms of rupees. Okay, and that will depend on the conversion ratio at a particular point of time. For example, a book may be supplied in 3 different dates, the actual purchase price may be different, even though the price of the book, the published price of the book is the same. So this will be an attribute of the supplied by relation. Therefore, in the entity relationship model, an entity also consists of a set of attributes. A relationship also consists of a set of attributes, and the attributes of a relationship are the attributes of the ensuing entities which participate in the relationship combined with the attributes of the relationship itself.
Borrowed by relation should have all the attributes of user, all the attributes of book, and attribute of date of issue.
Yes, the borrowed by relationship is a relationship between book and user, saying who has issued this book. Now, how to identify a book? To identify a book, you have to give all the attributes of the book. To identify a user is defined by all the attributes of the user, and this is defined by the attributes of the book and who has issued the book as well as the date of issue. So the attributes of a relationship are the attributes of the participating relations and the attribute itself.
Only participating attributes or all the attributes?
All the attributes. What do you mean by participating attributes? It is the participating entities.
It can be a book name and the user name. We can. Some key names.
The question is,
key attributes.
we have not come to the definition of keys. A definition of a book is by itself unique by its attributes, and therefore this uniqueness is taken up here. Now, whether a subset of the attributes suffice will come if the problem has got some more characteristics. We shall come to that later. Now, all relationships may not be binary. There may be ternary relationships. For example, in the banking example, In the banking example, we have got the accounts relation entity, which has got the attributes we have got the branches and we have got the customers, and we have a relationship which says that this customer has an account, this account in this branch. So we have got entities, 3 entities and a relationship combining all the 3 entities. So a relationship need not necessarily be a binary relationship. In fact, it need not necessarily be a ternary relationship. You may have 4 entities participating in a relationship. Consider the case of a institute where you have got students, staff, room, period, subject, and you have got this relationship called class, because for a particular class you will need students. These students attend the class, this staff takes the class in this room and this hour, and this subject is taught. So a relationship may have more than one entity, and the attributes of this relationship will be the attributes of all the entities and its own attributes, if any. Finally, an entity relationship may be in the same entity set. A relationship need not have but be between different entity sets. This is the staff and this is the reports to. This person reports to this person. In all organizations, you have people reporting to people and staff report to staff, isn't it? So once staff report to staff, you have a relationship between the same entity set. Therefore, a relationship may be between the same entity set, and in order to distinguish what is what, we have what is called the role of a relationship. We say manager and worker. That means this role identifies, see, this will have what attributes? This will have a duplication of the attributes of staff. Now, if staff has got attributes if it has got attributes employee code, name, department and address, then this reports to will have 4 plus 4, 8 attributes. But in order to identify which is whose attribute, because it is between the same entity set, we have to identify the role, that this is the manager, that means this person reports to this person. So to identify that, we put some labels on the links as and when required.
So now in the same case, suppose, for example, like attendance or roll call, there will be a student also who reports to the same person. So in
this manager will report to another set of persons. So
I'm talking about the student reporting to the manager now. There are staff reporting to that person, but there is also a group of students who also report them.
Okay. Now the question asked is that some staff report to staff. This is one type of relationship. Now if you have some students also participating in activities, and these students participate in the activities in such a way that they also report to this staff, then either we will have to have an entity which encompasses both students and staff, or we will have to have a different relationship between student and staff with a different reports to relationship. Any one of them we will have to take into account. The same one cannot be used, because this is a participatory relationship between these two. And you cannot say sometimes this will be staff and sometimes this will be student. So either we will have to have an entity which encompasses staff and student, or we will have to have a different relationship for students reporting to staff. Now we come to a crucial issue. Now entities and relationships look alike. Both have got attributes, both have got a set of attributes which define it. So if you look at it in one particular way, entities also comprises a set of attributes, relationship also comprises of a set of attributes. Now which one will you make a relationship and which one will you make an entity? That is a question. So let us come to the library database system and let us see. Will we have an attribute? One attribute instead of two attributes and a relationship. That is, instead of this, book, user and borrowed by with this date, the alternative is we will have a book user combination which will have all the attributes: accession number, author, title, publisher, date of issue, card number, name, address, etc. So the choice is between one entity expressing all the books, all the users, and who has borrowed which book, and this. This is the two choices that we have, because a relationship is also a set of attributes. This is also a set of attributes, this is also a set of attributes. It is not a question of efficiency that we will consider such now, whether there will be so many duplications of these attributes here or there. That efficiency issue we will tackle later on. Here we will tackle the issue of whether we are accurately modeling the information. Whether more space is being required, less space is being required is an issue which we shall tackle much later. Our point here is, and our botheration is, are we accurately modeling the system? A criteria which we will have for any entity in an entity set is that for a particular entity of that entity set, each of these values must be defined. Any entity of an entity set is identified by the values of its attributes, and these must be well defined. In a library, there may be books which are not borrowed by anybody. In that case, if we have this one as our model, then we will have some books which have these fields as null, unidentified, unknown. And that is something which we will not have at this level in the conceptual model. Therefore, we will immediately say that since a book can have no users, therefore this is not acceptable to us. Similarly, if a user may be there who may have borrowed no book, in that situation we will have to have a separate entity for this. And only those books which are borrowed by users will be defined by the relationship borrowed by. Let us consider another example. Let us consider the example of telephones. Will we have one entity set regarding the staff and their telephones? Will we have it as one entity set which identifies the name, address, employee code, telephone number, and telephone location? That is, we want to put the telephones of a staff in a particular place. Now, will we have one entity like this, or the alternative is we will have staff, we will have phone, and we will have I am putting some more attributes. Phone type, that is whether STD is allowed or not allowed. The choice between these two will be decided by a particular fact. If every staff member has a phone, then this is okay. It is still not okay. It is okay if every staff member has a phone and every phone has got an association with a staff member. Whereas this one says every staff member need not have a phone and every phone need not be allocated to a staff member. There may be a phone in the library. So, there may be a phone in the library. So, this says the phone number, type of phone and the phone location may be for a particular phone which may not be associated with a particular staff member. And there may be staff members who have got no phones. But this should be differentiated from the fact that both of them do allow a staff member having more than one phone or one phone being shared by more than one staff member. This is allowed in both of them. Here, this relationship takes care of the fact that this staff member may have a phone 4705. Another staff member may have the same phone provided they are in the same room 4705. This relationship will have both of these sets and they will be differentiated by this part, whereas this part will be same in this relationship. Here also you can have the same two staff members sharing the same phone, and here also you can have the same phone number with a staff member having more than one phone. That is there in both of these situations. So it is not this which differentiates these two. What differentiates these two is the fact that a staff member may not have a phone or a phone may not be allocated to any particular staff member. That is where this definition is different from this definition.
But in second case, if we want to know what is the phone number of the staff, have to look through the entire class phone list, and only then we can find what
We are not, the question is, if we want to find out the phone number of a particular staff, we have to look at the entire list of this has phone list. We are not concerned with how we will tackle efficiency at this particular point of time. We are tackled with the issue of being able to model the information that we wish to model. And if we are able to model the information that we wish to model, we must do it accurately. Regarding efficiency, we will come to it in the next phase. This phase is the phase of design, is the phase of conceptual modeling, and it is here we will bother about other things.